chemical lovers! Okay, we are going to talk about stoichiometry calculations. Then we are going to talk about reactions and substance in reactions.
First, we will see how chemical reactions are represented. This is by chemical equations. To understand it better, we will see an example. We read plus as react with and the arrow as produce. The chemical formulas in the left are reactants and the formulas in the right are products. The equation should always be balanced. This means that you must have the same amount of substances on the both sides of the equation.
I'm going to talk about some simple patterns of chemical reactivity, where I will analyze three types of simple reactions: combination, decomposition, and combustion. A combination reaction is where two or more elements combine to form a single compound. For example, the barium metal and fluorine gas will combine a highly exothermic reaction to form the salt barium fluoride. A decomposition reaction is a process that some chemical compound undergoing which caused by an external agent, two or more substances of simple chemical structure originate from a compound substance. For example, the calcium carbonate separate on calcium oxide and carbonate dioxide. This reaction is a rapid reaction that produces a flame. Most of these reactions involve oxygen from the air as a reagent. For example, the hexane to molecular oxygen produce a carbonate dioxide and water.
3.3 Mass formula. The chemical formulas and equations have a quantitative meaning since the subsequents and coefficients have pressurized quantities. For example, H2O. An example for H, it's either two hydrogen atoms, and O, it's one oxygen. 3.3.2 Present composition of chemical formulas. It is the present base with which each element contribution to the substance.
Well, everything around us is made of atoms. For example, 1 tablespoon of water is conformed by 2 times 10 to 23 atoms of water. To avoid this problem, the chemist advised a special unit, named mole. Mole means quantitative information in some objects, maybe molecules, maybe mass, maybe atoms. Then create the Avogadro's number. The Avogadro's number marks the relationship between molecules and number of mole. Well, we can apply the concepts in the next exercise. Calculate the number of atoms of hydrogen in 0.35 moles of glucose, C6, H12, and O6. We have to base in this law: moles, then molecules, and then atoms. From the biggest thing to the smallest thing. We have to start. Okay. Atoms of hydrogen, it's 0.35 moles of glucose, and then the conversion factor. To cancel the units, we have to put the mole in the below part to cancel it. Then 1 mole has the Avogadro's number of molecules of glucose. And then 1 molecule of glucose has 12 atoms of hydrogen. Then we cancel the units, moles, molecules, and we obtain atoms. The next operation is 2.53 times 10 to 24 atoms of hydrogen. Well, the main advice to solve these problems is to base in the law. Moles, molecules, then molecules to atoms. If we want to get the number of particles, well, it is another process. We have a coin of copper. We are going to assume that it's completely of copper, 100% of copper. Well, the coin has 3 grams. So 3 grams of copper, and then the conversion factor one mole of copper has 63.5 grams of copper. Well, 1 mole of copper has 6.02 times 10 to 23 atoms of copper. Remember to cancel the units. Grams, grams, mole, mole, and we get atoms. The operation marks 3 times 10 to 22 atoms of copper in the coin. This coin has 3 times 10 to 22 atoms of copper. Remember the last law. We have mole, then molecule, and then atoms. My chemical lovers, see you next weekend. Take advantage of this information.